Hello everyone, today we're going to have a new discussion and that is about solving equations transformable to quadratic equation. The first thing that comes to our mind every time we heard the topic about solving equations transformable to quadratic equation is how to transform rational equations into quadratic equations. And to transform rational equations into quadratic equations, the first step is determine the LCD, or what we call the least common denominator. After you determine the least common denominator of the given rational, multiply both sides of the equation by the LCD. And of course, the last step is write the resulting equation into standard form. Let us try this example. Find the least common denominator of the given rational 2 over x minus 3 plus x over 2 equals negative 1 half. And of course, we're going to determine first what is the least common denominator of the given rational. And since the objective is to remove the denominator of the given rational or to transform the rational equation into quadratic equation, so meaning we're going to make now x minus 3 equal to 1, and that is by multiplying the rational 1 over x minus 3 by x minus 3, and we can also make 2 equal to 1, and that is by multiplying it by 2. But since there is no common between 2 and x minus 3, so therefore, the product is the least common denominator. So that's why the LCD is 2 times the quantity of x minus 3. And after we identify the least common denominator of the given rational, so this time, we're going to proceed to step number 2. And that is multiply both sides of the equation by the LCD. And since the least common denominator of the rational is 2 times the quantity of x minus 3, so meaning we're going to multiply both members of the equation by the LCD. So that's why it becomes 2 times the quantity of x minus 3 times the given rational, which is 2 over x minus 3 plus x over 2 equals negative 1 half. Then times the LCD. Now we're going to simplify. We're going to divide now x minus 3 by x minus 3, so it become 1. So that's why we're going to multiply 2 by 2 plus we're going to multiply 2 times the quantity of x minus 3 by x, then divide it by 2. So 2 become 1. So that's why it become x times the quantity of x minus 3 equals. We're going to multiply or simplify the right member of the equation. Of course, we can cancel. We can make now 2 and 2 equal to 1. So that's why it becomes negative 1 times the quantity of x minus 3. And again, simplify the resulting equation. And of course, 2 times 2 become 4. X times x become x squared. X times negative 3 become negative 3x equals negative 1 multiplied by x, it become negative x. And negative 1 times negative 3, it become 3. Simplify again. So it becomes x squared minus 3x plus 4 minus 3 equals 0. Why? Because we transfer negative x to the left. We also transfer 3 to the left, so that the right member of the equation becomes 0. Then after that, we're going to transform the resulting equation into standard form. So that's why the standard form of the resulting equation is x squared minus 2x plus 1 equals 0. After we understand how to transform rational equation into quadratic equation, so the next question is how to solve rational equation transformable into quadratic equation. Let us try to solve this equation. 2 over x minus x plus 1 all over 5 equals negative 4 over 5. And of course, we're going to transform this rational into quadratic equation. And that is by identifying what is the LCD, multiply both sides by the LCD, and then simplify the result. And since there is no common between x and 5, so meaning the product between x and 5 is the LCD. So the least common denominator of the rational is 5x. After we identify the least common denominator of the rational, so this time, we're going to proceed to step number 2, and that is multiply both sides of the equation by the LCD. And since the LCD is 5x, so that's why the equation becomes 5x times the quantity of 2 over x minus x plus 1 all over 5 equals the quantity of negative 4/5 times 5x. And then of course, we're going to simplify now the resulting equation, and 5x times 2 over x, we can cancel now x, so it becomes 1. So that's why it becomes 5 times 2, then minus 5x times x plus 1 divided by 5, so 5 become 1. So that's why it becomes negative x times the quantity of x plus 1 equals negative 4 times x. Why? Because we can eliminate now 5 and 5, so it become 1, and then so that's why it become negative 4 times x. Then we're going to simplify now the equation. What is 5 times 2? Of course, the answer is 10 minus negative x times x, it becomes negative x squared. Negative x times 1, it becomes negative x equals negative 4 times x, negative 4x. And then we're going to write now the resulting equation into standard form. So that's why it becomes x squared minus 3x minus 10 equals 0. After we transform the resulting equation into standard form, then this time we're going to decide what is the best method to solve x squared minus 3x minus 10 equals 0. Is it by completing the square, by quadratic formula, or by factoring? Now, since the resulting equation is factorable, so meaning we're going to use now factoring. And the value of a equals 1, and the last term of the equation is negative 10, so meaning the middle term is the difference between the factor of the last term. So that's why the factor of the equation is the quantity of x plus 2 times the quantity of x minus 5 equals 0. Why? Because if you're going to find out what is the value of the outer product, the answer is negative 5x, and the inner product is 2x. And of course, if you're going to get now the sum, then the difference is negative 3x, or the sum is negative 3x. Now, by applying now the zero product theorem or the zero factor property, we're going to equate now x plus 2 equal to 0 and x minus 5 equal to 0. And both are example of linear equation. And then x plus 2 equals 0. Of course, the value of x equals negative 2, and x minus 5 equals 0. The value of x equals 5. So meaning, the solution of the quadratic is negative 2 or 5. After we determine the roots of the resulting quadratic equation, which is negative 2 and 5, of course, it is important to check it to the original equation to see if both roots satisfy to the equation. And then after we replace x equals negative 2 and x equals 5 to the original equation, which is 2 over x minus x plus 1 all over 5 equals negative 4/5, we may observe that negative 2 and 5 satisfy to the original equation. So therefore, the solution of the original equation, or the solution of the quadratic or rational equation, is negative 2 or 5.